In this video, I'm going to show you how to make a finite element mesh and then run a simple solidification analysis. Most people agree the finite element method is better than the finite difference method, but lots of people think it's too hard to make a finite element mesh. In this video, you'll see finite element meshing is easy. So let's take a look at the STL file. You see it starts off, that's the only file in the folder. Open the pre-processing software, read in the STL file, and here it is. As you can see, it's very complicated casting. Lots of small details. Notice too the many overflows and vents. So open up the mesh generator, bring in the STL file, and then I'm going to specify a base criteria for meshing. With that complicated casting, I'm going to use 1 millimeter. Then I specify an output file name, and I click Run, and there it goes. It starts to run, and as you can see, the temporary files are being created in the folder. So while it's running, let's go back to the STL file and just investigate it a little bit more closely. Clearly you can see all sorts of channels and contours in this complicated casting geometry. If you zoom in, you see a little bit better how those channels are defined. Lots of smooth curves, lots of radii. I can go in and take cut sections. I'm going to take a cut section at 171, and that's going to go right through an overflow so that I can compare the thickness of the gate to the overflow to the thickness of the casting. You can see maybe it's a third of the thickness of the casting, that overflow gate. It's probably about 1 millimeter in size, maybe a little bit more than that, so it's not very thick at all. And you might have noticed too, I'm going to zoom in one more time. The mesh is done, so move this window over here. There's also, a very thin section near that overflow. Looks like it could be flash, and it's much thinner, maybe 1/10 of the thickness of the overflow gate. So some nice thin sections in this casting. So here we go. This is the finite element mesh on the left. Zoom in a little bit, you start to see the elements making up the model. Switching to gray allows us to see a little bit better of a view, and it looks very similar to the STL file in this perspective. Here you see that there are element lines making up this model, which indicates it's not the same as an STL file. It's actually an element mesh. This mesh looks nice, but it is of little use except that it includes extra elements, shown here, that can be used to represent the die steel in a solidification analysis. Go into the thermal software now, and I can create a parameter file based off of the output file that we just created. And click OK, units of millimeters, and ID of 1 for the blue casting. And then go to Run, and quickly I get out this temp.sol parameter file that I can use in the thermal software. Alright, now click Run Cap 1 and Cap 2, and there it goes. This simple solidification analysis has started. So while it's running, let's go back to the mesh and just take a closer look. First going to return to showing just the casting elements. And I'd just like to point out again how well the finite element method does in defining the curves and the contours. Zoom in closely here and you can see all nice radii are defined in the finite elements, just like in the STL file. All the channels are well defined. And you take a look at the overflows. Zoom into them and you see that they look very nice. There's no holes or anything in the gates. Turn it around to the back side, you see the pad there, it looks good. And the runners too. Let's go down and check them out as well. See, just like the overflows, they look really nice. So I'm happy with this mesh. And I can also take a cut section just like I did with the STL file, and go take a cut section at the same coordinate, 171, to get that cut section through the overflow and the flash. Let's see. Hey, look at that. The overflow gate looks great, and the flash comes through too, so that's really nice. Okay, so in the meantime, I can open up the post-processing software. I can open up the geometry file, which is derived from the output file, so it's also a finite element mesh, as you can see. This is used in the thermal software for calculations, and it's also used for post-processing. So as you can see, just like in the out file, the geo file is well defined, has a lot of elements that are defining all the curves and channels of the casting. So it looks good. The thermal software is still running, but I can get ready by going to Post, Single Node of Results, and if I want to view temperatures, for example, I would change the mode to temperature. And once the solver has finished, oh, there it goes, it's done. Click Plot, select the a1.node file, that's the output file. And the first thing we see is temperatures on the surface of the casting. This is at the end of solidification, so it looks reasonable. The outside is cooler than the inside. If I wanted to look at solidification time, I'd switch to time. Click Plot again. And here's a view of the solidification on the surface of the casting, which is mostly close to 0. But if I click ISO, I can see the solidification pattern. And just look for, initially it's all drawn in red, that means it's liquid metal. And as time goes on, it gets replaced by gray, and hot spots remain in the casting. So those hot spots are, of course, prone to shrink porosity. Show it one more time real fast here. So that's it. So starting from STL file to casting, in less than 8 minutes I was able to create a finite element mesh and have a simple solidification analysis performed. Thank you for watching.